impact air quality, but they certainly are beautiful explosions. The vibrant colors and the various patterns look so stunning. When we light them, the increase in temperature causes these explosions. Did you know that the first firecracker was invented around 2,200 years ago in China? That's way long back in time. In this video, let's find out how temperature affects the reactions. Explosions are combustion reactions that occur in a fraction of a second. In contrast, the corrosion reaction that rusts a bridge may take years. Various factors come into consideration while deciding the rate of a reaction. Let's study the effect of temperature on the rate of a reaction. Consider the reaction between sodium thiosulfate and dilute hydrochloric acid to form sodium chloride, sulfur dioxide, water, and a yellow precipitate of sulfur. As an example, take 50 cc each of dilute sodium thiosulfate solution in two separate conical flasks, A and B. Keep accurately measured 5 cc of dilute hydrochloric acid in two measuring cylinders. Keep a paper marked with a cross on the table. Add hydrochloric acid into the flask A. Swirl the contents and place the flask on the paper. Start the timer immediately. Look down at the cross from above. When the cross disappears, stop the clock and note the time taken. Now, heat the conical flask B to about 30 degrees Celsius. Add hydrochloric acid to it. Swirl the contents and keep this flask on the cross mark. Again, record the time for the mark to get invisible. You will notice that the cross disappeared faster in the second case, when the temperature of the reaction was higher. From this, you can conclude that the rate of a reaction increases with the rise in the temperature. Let's study why this happens. Consider a hypothetical situation when the reactants A and B are intermixed. All molecules have different speeds and hence possess different kinetic energies. When these molecules collide with each other, some collisions result in product formation, while others do not. This is because the colliding molecules must possess minimum threshold energy, called the activation energy, for an effective collision to occur. Now, let's apply heat to this system. The molecules absorb energy and start moving faster. This implies that now there is a greater fraction of molecules having energies higher than the activation energy. This increases the number of effective collisions, and hence the rate of product formation increases. In fact, it has been experimentally verified that the rate of a reaction doubles itself for every 10 degrees Celsius rise in the temperature of the reaction. This fact is well demonstrated by considering the Maxwell-Boltzmann distribution curve. At a higher temperature, this curve shifts to the right. Clearly, the number